Well, welcome back to the channel. This video is going to be a continuation of the motor coil experiments that I was doing back in a couple other videos. I'll link to those. This is the motor out of the Capstan motor out of the 122 Mark III in the last video that got this transplanted. Just to catch you up, I had rebuilt this motor and it was operating a little bit erratically. And what was happening was, when it was cold and first turned on, for the first 10 or 15 minutes it was running in spec and doing fine, and then after 10 or 15 minutes it would double its wound flutter numbers. So it would go from about 0.04 to around 0.09, and that was unacceptable. And so this motor had been tampered with quite a bit, and probably more than once, and I'm not entirely sure what the story is on it. It was a backup deck, a parts deck for the owner whose deck I was working on previously. So he sent me the transport out of that parts deck, and I transplanted the motors and rebuilt the other one, and it worked fine, and that's now back in his hands, and he graciously allowed me to experiment with this motor. And so I plan to replace these 4 coils with the ones that I have made and wound myself, and see if I can tame the problems on this one. And I'll link to those other videos of the making of the coils and all those experiments and getting to that point. This is, you can see the one here on the right hand side, the one coil that has a little bit more adhesive on it than the others, and that was the one that I had removed in a previous video, and unwound one of the windings that had broken off, and resoldered that one back down to the pad. The problem that I ran into was these windings are so brittle on this. Even unwinding it and picking out a new one and so forth, they were just super brittle, and copper work hardens, and so it would require annealing and so forth. And I don't know that that's really possible on something like this. Maybe it is, I don't know, but I've never done it and I haven't experimented with it. So what I'm going to do is replace these coils with new ones, wound in shop here, and see if what I believe is the problem with this motor actually is the problem or not. I've had need for coils myself. I've had others asking if I could, had a source for them and so forth. I did try to get a couple of companies interested in winding these for me in small quantities, and of course nobody's interested in doing that, at least that I could find. And so I did it myself, and like I say, this is still largely experimental. Just going to take off the hall sensors there. Those can also be desoldered easily, but they still have to come off of the adhesive there. Get a little closer. You can see the white grease that I applied to the thrust bearing back when I first serviced this one, and also the insulation in the slots they go through, that the leads go through. That was, like I say, this motor had been tampered with quite a bit, and including that thrust bearing screw adjustment had also been tampered with, and I suspected that that's how the windings got broken, was putting a flat screwdriver in there and having it slip off. I just want to make sure that my template is accurate and correct, and it appears to be. This will be my spacing template for when I glue the other ones back on, the new ones. That was another one that I made, but I like the first one because it centers around the bearing, and so that's my reference, is that center bearing. So I'm just marking that these coils are slightly larger than the other coils that I measured and made this template around, so I'm just kind of making a note of that and where that is for future. Let me grab one of the ones out of the set of 4 that I'll be replacing it with. And I'll show you what that looks like in comparison. Now in mine I have left the mandrel that I used, or the form I used to wind it around. You can see mine's just a little tiny bit smaller, and in measuring them they are slightly higher impedance by about 100 millihenries than these. I don't think that will be a problem, but I believe the reason why is I think I wound mine more tightly than they wound theirs. And so on the next batch, I'll try to loosen up the wind a little bit. If anybody does know, so I think the factory ones were around 700. I'll have to look and see. I wrote it down, of course, but I think the factory ones were around 750 millihenries, and I think mine were closer to 850. It might have been 650 and 750, but at any rate, they were about 100 millihenries greater inductance. So if there's anybody out there that knows how that might affect things, to me, it doesn't seem to be a problem, but I'd be interested in your comments. So to get these off, I'll use, this is actually a polycarbonate chisel. It just happens to be handy, sitting right here next to me. The better material would be Teflon, but I'd have to stop and go make one of those quickly, and I'm really kind of curious to see if this is going to work out or not. So I'm kind of rushing through this. I'll probably end up doing it again. So I'll just heat this from the bottom side. I'm trying to save out these coils if possible, because 3 of them are okay. The one was bad and probably not reusable. Most of the epoxies and things, and I think they actually use phenolic resin on these to bond them, but even phenolic resin has a temperature that it'll break down. It's a little bit higher than epoxies, but the idea that I've found, I do a fair amount of removing parts that are adherent in place, and what I find is to get them up to temperature, you measure the temperature is fine, but to get them up to temperature and then kind of walk away. And especially with epoxies, they will break down and sort of crumble at the temperature that makes them easy to remove. And I've done quite a bit of this, and it's just patience. And if you try to get in a hurry, and things break and warp, and with a lot of the epoxies I work with, you can actually smell when they've reached that temperature. It's just something that you get used to knowing. So it's the idea for me is warm them up, get a cup of coffee, come back, and things will generally pop off. There we go. We're starting there. I have no doubt that bottom layer will probably come apart because it's also the same temperature as the rest of the backing plate. So I still think I can save these out, or save them out for our soon to be 51st state. Just kidding, guys. Should pop out of there now. I'll do this one in real time and then probably fast forward through the rest. Now what I'll do is I'll just break the bond and try to disturb them as little as possible so that they'll, refreeze, they'll cool back down, and hopefully most of the coil will remain intact. Now this is the one that I epoxied on, and so let's see if there's a difference. Yeah, maybe a little bit. Yeah, maybe not. I don't know. If anybody knows what adhesive they use to bond these, I'd very much like to know. Now, if you're interested to know, kind of watch some of the other videos pertaining to this, I think what I'll do is I'll try to put cards up here as much as I can, but I think I'll also link the whole, or maybe even make a playlist out of the several videos that are involving these, and I'll just put them in a playlist, and then that'll make it easier, I think, for anybody that might be interested. So that's the plan there, is just to kind of get them off of the backing plate and just let them cool back down on their own. Now, had I used a Teflon chisel, that would have held up to the heat better and not warped, but this still worked out fine. Okay, so that's it. They're debonded. Let them cool off, come back, and get them out. Okay, so you can see here how much tampering went on just on this part of it. That screw is what sets the end play, and you can see that's been scratched up. Somebody has been adjusting on it. That's fine. I mean, I realize people they have a problem and they see screws and they start turning them. I do it too. I've done it. That's how I learn. But in this case, I believe the driver slipped off that screw head and probably damaged one of the leads, and it was repaired. And if you look at one of the first videos, you'll see the repair was made on that. And so, very likely this motor's been having problems for a long time, and that's what led to the attempts at repairing it. And, I'm doing the same thing. I'm attempting to repair it. Obviously, these aren't available anymore, but, even if they were, it's still valuable to have the ability to rebuild these motors that don't, that aren't available, or maybe the parts decks are starting to be unavailable. I think a lot of us don't consider anything a parts deck. We feel like we can repair anything that's wrong with them, and so, it's good to have this ability, or at least be working on the ability, which is the point that I'm at. So that was a pretty good adhesive job there. You can see that it's bonded very well. I'm taking off a little bit more of the paint than I want to. Now, this is the factory adhesive, and it's on there a little stronger than what my bond was. That's why I think it's probably a phenolic based thing. Yeah, that's not very sharp. That that should be just pulling right off of there without a problem. Should be peeling off. Should be able to get under that and just peel that right off. Let me change blades here. These are easily sharpenable, but it's also nice to have some brand new ones when a guy's in a hurry and just wants to get on with it, not stop and sharpen. Okay, let's try this. There, that's how it should work. It should just peel right off. Just like that. Perfect. See the difference between how this removes and how the epoxy one removes? That's why I think it's probably phenolic based. All right, got it all cleaned up. Took the thrust bearing out, cleaned up all that, cleaned up in through there. I gave it a quick scuff with some red Scotch-Brite. There's my template. And that's how it needs to be clocked right there. I don't think it matters. I think it's just for access to the leads, getting the leads through the access slots there. So now I just need to figure out how to attach this. This is not, kind of can't see it, but it's not, that little red ring around the other side is a spacer. So this isn't sitting down flush against the plate. It's spaced off of that plate by, excuse me, 20 or 30 thousandths, so that it doesn't adhere itself to the plate. So I think what I'll do this time is just put a spot of super glue in a couple of places to hold that on, and then just peel it off when I'm done. Now ideally I think it would be nice to shape it so that it fits around the plate, and I'll do that at some point if this works out. Okay, so my plan here is to go just like this, position it, and then I've 3D printed some pads, some clamping pads. I'll just set them up there on top and put light pressure on with the smallest clamps I have. Just like that, and hold them down. So that's my plan. This is the adhesive that I'll be using. This is a structural adhesive. It's not necessary, but I have it out. But I was using it on another job, and so it's easily available. You know, really any high quality epoxy would do this just fine. Not the 5-minute epoxies. I think maybe people know this, but the 5-minute epoxies aren't waterproof, and so they will absorb moisture vapor from the air, and they'll eventually break down, and it doesn't take long. In a humid environment, they'll break down very quickly. And so I avoid those for anything other than it's very temporary jobs. I call them 5-minute epoxies because that's pretty much what they're good for. So that's it. I've already done the other 3. I'm just doing the 4th one on camera. doing is just kind of centering them, left and right by eye, and then pulling them back against the outboard edge. Actually would have preferred if I had some lighter clamps available to me, but I don't, so I'm using what I have. It doesn't need much clamping force, just the lightest amount to hold them in place. Okay, so that's how it is. Now this adhesive that I'm using is has a shelf life, and it's a little pricey. And so the way I store these is I use argon gas to displace the air that's in the can, and then I keep them refrigerated, and that extends out the life. Any inert gas would work in this situation, whatever's available. I happen to have argon. And then I'll keep them refrigerated. They can also be frozen. I use refrigeration because it takes less time to thaw. But I am told by chemists that freezing them will extend it out even longer. Okay, so here it is, and I made a little bit of a mistake on this. This is structural adhesive, and it requires 24 hours cure time. It can be quick cured under heat, or a lot of times I use infrared heating. But in this case, I didn't want to wait 24 hours, so I put it on top of a shop heater and ended up melting one of those 3D printed pads into one of the coils. And so removing it damaged the coil. And so I had to go back and remove the damaged coil and put another one in from another set. I make these in sets of 4, obviously, and that set was a little bit, had fewer windings in it and had slightly lower inductance. And so one of these coils is somewhat less in inductance than the other 3. Now, I'm not going to let that bother me at this point, because this is still proof of concept. So any sort of positive result to me will be acceptable. And I can make as many coils as I wish to make and replace them as often as I want to. So I got in a little bit of a hurry, but I'm really anticipating getting this thing back in the transport and testing it. And so, yeah, I got in a little hurry. It's okay. It actually probably would have been fine if I didn't have so much clamping force, if I had lighter clamps, or if I hadn't 3D printed those pads out of plastic. If I would have cut them out of wood or something else, they would have been fine. So you can probably see that I've scraped and pre-tinned these off camera. There's a little glob of solder right there on one of them. These are so fine. They're just slightly, they're like a really thick hair. And boy, I sure am gaining a lot of respect for the people that assemble these things the first time around. I'm sure they have fixtures and things like that to make this easier, but still, you're still dealing with a very fine strand of hair. Yeah, get the back plate screwed back on. I'll just speed through this. You don't need to watch me screwing in screws. Centered here. Okay, so let's get these leads tacked down onto the pads. They're still fine and difficult to work with, but at least they're not brittle, and breathing on them causes them to break. Just get them positioned and then look on the other side and make sure I've got them correct. Kind of give myself a little bit of slack here and keep them centered so that when I go back and put the potting material in those slots, they'll be able to move around a little bit with heat. Yeah, I'll just do one or two of these and then fast forward through the rest. You can see that I've pre-tinned both the pads and the leads. I'm going to add just a little bit more flux on here because those last two didn't quite wet out the way I wanted them to. That's much better. So if all is well, this will rotate in the correct direction. I did wind the coils in the same direction that the factory coils were wound. I made a conscious effort to do that. Just check it out here. Get over here so you can see the meter. Okay, I'm not making good contact there. Okay, I don't like that. I know it's not the coil. It shouldn't be the coil. It should just be the contact. So maybe I didn't get the insulation scraped off on that one well enough. You can't see that. Yeah, so I'll bet that's all it is. I just didn't get the insulation scraped off adequately. And that's also the one I didn't flux. Well, let's take care of that. Let's see if that does it. There it is. Okay, I did a light cleaning on that. I'll go back and clean it better later. And I am not tacking down the hall sensors. This is just a test. So they're going to be there just kind of loose. I'm also not insulating the leads. I just wanted to get this thing together and see my results. Now, right this minute, I am not going to set up and check for end play. I'm just going to do it like this and see if I've got what I think is sufficient end play for the test. I'll do this later, assuming that things work out correctly. It's not a difficult thing, but it does take some setup. And like I said, I really want to get this mounted and tested. Now I did clean and lubricate these bearings, of course, and so I'd want to put on my little oil seal washer. And I'd also like to say that I am offering these now on my eBay store, along with the idler tire for the standard Mark 0, the standard 122, the 122 Mark II, and the 122 Mark III, and all the iterations of all those decks in the two head models and so forth. So I offer those as a set now. I'll put a link below. I don't sell them separately because it's really not worth it for, I think, the $4 I'm charging to sell one individual washer. But if you buy the idler tire, you can also choose to include this seal along with it. So I'll put a link below on that. Just clean this up now, clean the oil off of the capstan shaft. Get this thing wired back together. I have cut and stripped these leads. And I've shown this many times before, but the way I do this is I get the solder on the end and leave about a diameter of wire untinned. And that's for strain relief, and it's a good way to do it. I don't want to get any solder or flux underneath the insulation. Now just clean off the flux. Again, I'm using Kim wipes or something that doesn't shed fibers. I don't know, I think maybe people know this, but coffee filters are great in a pinch for a very clean towel that doesn't shed. So sometimes when I run out of Kim wipes, I will use a coffee filter. They're fine. And then the other part of this is leaving the that bare wire that's untinned. In other words, not running it right up through the hole, but leaving a little bit of that exposed wire as a strain relief. That's the purpose of it. And on these decks particularly, they used such fine wire that a lot of times I'll open one up and these leads will all be broken, or one or two of the leads will be broken, or you touch them and they break, or you breathe on them and they'll break. So it's just a good way to help give them a little better life. Whoops. That one doesn't want to stay there. Now this resistor, I mentioned this before, I don't know why this resistor's there. It's not in any of the other ones that I've worked on, that I can recall anyway. But it was there when I got it, so it's staying in place. Now this transport is locked up, and it's no doubt the C gear. This is the parts transport that the owner sent. And this is very common, of course, to see the C gear damaged and broken or about to break. And this is not, I think a lot of people might think this is a factory defect. It is not. This is a maintenance item. Spur gears like these require quite a bit of backlash in order for them to function correctly. And so it's been the custom probably since the beginning to place one softer gear, a gear of softer material in the train in order to quiet down the gear train. And this is a little bit of a noisy mechanism. And so this gear that they placed in here is a different material than the others, and it's softer, and it breaks down. It has nothing to do with the lubricant, I don't think, anyway. I just think that the material itself is one that breaks down. So it's typical. They will all need this replaced, and there it is. It's no longer locked up. So I am not going to do a service on this transport at this point. I'm only doing what's necessary to make it operational. And so when I look at my results, my wound flutter, I'm not expecting it to be, down in the range of a factory spec. I'm just expecting to see consistency in it. If it's, 0.1%, I expect it to be 0.1% the first 20 minutes and an hour and 20 minutes later. That's what I'm looking for. And I'm pretty hopeful that it will be, apart from that one coil I had to replace that had the lower inductance than the other three. So that might throw things off a little bit. But, we'll see. I'm getting closer. We'll see what happens. Okay, so I'm just going to put a little tiny bit of grease in those to make sure everything's operational. And this is fine. You can see I'm not even replacing the idler tire on this. I just want to get it in the deck and get it running. Just picking off a little bit of grease off of that gear so that I can get my, I can snag my retainer. Okay, let's see how it goes. Isn't a great camera view here, but I think you can see what's going on. Okay, that's operational. It's good enough for the test. Now, throw this back together. I always take the side screw out of habit, and it's not necessary. It's only those first three that I put back in that need to come out to service that. I'm just going to clean the heads, clean the tape path, and at least get this pinch roller cleaned up as well as I can. Not going to take anything apart at this point. Kidding me? Give everything a quick degaussing. Again, I've never had this transport operational, and so I have no idea how it functions, if there's anything wrong with it. Obviously the motor was put in the other deck, and so this is all fresh to me. I have no experience with this transport at all. All right, let's get this back together. Oh, there's a little detent that this has to fit into. Okay, that all looks correct. Now I just need to go find a machine to put it in and see if it runs. So I'll be right back. Okay, I found one that my notes say that the transport isn't operational, but everything lights up correctly, and I hope that this one will at least have an output signal. That's all I'm looking for. The power and an output signal. Obviously my leads aren't tied up the way they would be normally. All right, I'm connected. I was going to leave the head leads off initially to fire this up, but I think I'll just go ahead and put them on. I really feel like this is going to operate. In fact, while I'm doing this, I think I'll go ahead and hook it up to the scope as well. All right, I got the cameras set up. One on the front of the machine and one on the scope. Turn it on. Now you're probably not going to be able to see this, but when I activate the tape sensor, it does come on. And I can see it from the top. This is turning. No funny noises, nothing like that. Tell you what, let's put a little mark on it so you can see that it's turning. Okay. That's a good sign. I can see that it's not overspeeding. Okay, this is my worst calibration tape. And this is the one I'm going to trust in this machine at this point. I've recorded a signal towards the end of this, so there should be a signal at this point in the tape. Let's see. Oh, here we go. Okay, so I've got I've got output on the meters. That's a good thing. It's obviously not overspeeding. You can see that in the tape movement. Let's bring in the scope. Okay, so right out of the chute, it looks like I'm maybe 0.08 on the wound flutter numbers. I've got no problem with that. Again, this transport is completely overhauled. It hasn't been touched other than what you've seen me do. So 0.1%, again, no problem. It's operational. Okay, this is a good sign. Yeah, let that run through for a while, do some more, get some time on it. At this point, I'm thrilled. This is the first time I've ever done a motor coil replacement like this. All four coils on a problematic motor, and I'm already calling this a success at this point. Now I do have a spike there that I can look at. Okay, I'm just going to let this go for a few minutes here and watch it. And then I think what I'll do is just let it run for an hour and then come back and check it again. So, you know, I'm seeing numbers of maybe 0.08 to maybe 0.1%, maybe 0.11%. That's kind of where I'm seeing it. Let's go back to the original part of the tape here that was recorded by the company I purchased it from. That was my signal, and that was off a JVC deck. This tape had, right from the start, it wasn't an expensive tape, but it had dropouts, one big dropout in it. And so I just never really used it. And I never thought it was very well made. But it's great for doing things like this. And at this point, I'm not willing to trust my factory reference tapes on this transport. Okay, so this is the original signal. Okay, so that's not bad either. Actually fairly reasonable. Curious to see if my spikes will be at the same frequency. Okay, so now I've had this running for actually about 2 hours. And let's see where we're at now. Okay, so this is slightly higher than it was at this point in the tape a while ago, 2 hours ago. But it is not, excuse me, it is not double the way it was with the old coils in it. So again, the other coils, the original coils went from 0.04 to about 0.09. This looks to be going from somewhere around 0.08 to maybe, 0.11. That's a huge improvement. And again, I've got one mismatched coil in this assembly. So I'll obviously run this for many hours and see how it does, but at this point, I'm going to call this a successful proof of concept. I just want to let this run through and see what kind of spikes I'm getting at which frequencies, and it looks like I've got a pretty good sampling right there. Yeah, I think that should be enough. I've definitely got a sampling here. Let's kind of see where the spike is. Right, that one there, 6.3 hertz. Yeah, 6.3 hertz. I did not take the time to balance the flywheel on this, and I believe that, not only that, but the way it's pulsating, it almost looks like that might be a balancing issue on the flywheel. Very possible. Look at that, 6.3 hertz. And that certainly is okay. So it is running a little bit fast here. Of course, I have pitch control on this deck. Let's just give it one more quick test at somewhere closer to 0. I'm also just kind of noting sorry, I'm looking at the numbers. I'm noting the speed consistency. Of course, I'd have to let that run for a little while, but it's not that bad. Okay, I think I'll try my most recently shop-made tape and just compare it. So you can see I don't even have this transport screwed down. Everything's just loose in here. Now I've got this running on the pitch control at closer to the right speed. So yeah, right there, about the same. getting a little bit more. I mean, it's almost, I would call this wow. If you look at the meter on the right, how it's kind of pulsing there, kind of breathing, that's more like a wow than it is a flutter. And you know, that could very well be that out of balance flywheel. So when this comes back apart, that's going to be the first thing I'll check. So yeah, this was a long video, but if you stuck with me through it all, I do thank you for it. I'm calling this test successful, and I just plan to press on. So thank you for watching. Catch the other videos in the description if you'd like to, and we'll see you again on the next one.